Okay, here's the a similar example to the previous, but this time I've got two terms with two variable terms on opposite sides of the equation, but they're both negative. I want you to show you that the process doesn't change at all. And I've already got the model down here, so I'm going to ask the same question I asked myself before, just to be consistent. It really doesn't matter ultimately, and I'll show you why. But which is greater, -2 or -4? -2 is indeed greater than -4. So I'm just, for whatever, just because I prefer, not word, it's just to be consistent, I'm going to eliminate the variable terms on the side with fewer of them. -4 is actually less than -2. So how am I going to get rid of or cancel out those -4x's? The same way I did before, with 4 positive x's. But if I do that to the left side of the equation, it's no longer balanced unless I also do it to the right side of the equation. Now, in black, I will circle that equals 0. So there's no weight there. But over here, two of those positives that I added cancel those two negatives. So that equals 0. So what remains is 5 equals 2x plus 9. And there I would take it from there um, using the x box. Okay, a moment ago I mentioned that it didn't really matter to which side of the equation I gathered the variable expression, the variable terms to. Let me show you what I mean by that. Let's start over and suppose I want to cancel out these two negative x's. I would put two positive x's over there to cancel them out, and I would put two positive x's over here to balance the two positive x's on the right. And then I would notice that here I have a net value of 0, no weight, and here I have a net value of 0, no weight. So what's left over, which I will circle in purple again because I like purple, I've got negative 2x plus 5 equals, over here, 9. And I could carry on with the x box from there. Now, look at this. Negative 2x plus 5 equals 9. Compare that to 2x plus 9 equals 5. They look very similar, don't they? And they would actually, it's the exact same equation in a different form. The two equations would have the same exact solution. So that's a demonstration of how it doesn't really matter which side of the equation you gather the variable terms to, as long as you do it right.